Okay, let's go through a couple of example problems from the practice packet that I gave you. You're welcome to pull this up anytime in class when we're working on this if you'd like to review it again. But let's look at like number 11 here on, it's noted as page 51, and then we'll look at 52, the back side of this. We'll choose an example problem from that side also. So I'm looking at number 11 here. The first thing I want to recognize is what form am I looking at? In other words, what kind of function is this, and what forms of that function happen to exist. So I have an x times an x, which means we're looking at an x square as my highest power, which gives me a quadratic. If they hadn't already told me that, that's how I would check. Quadratics come in a series of different forms. This one is factored form. Factored form highlights our x-intercepts. So before I go anywhere else, I'm going to quickly figure out what my x-intercepts are. So what does x have to be to make my y be 0? Well, if x were positive 2, then 2 minus 2 would give me 0. And if x were negative 6, then negative 6 plus 6 would also give me 0. So remember, if this is 0 or this is 0, then the whole output will, sorry guys, if this is 0 or this is 0, then the whole output will be 0. Okay. Y-intercept, we could come to that one next. I'm going to come down to stretch though first, because the stretch is just that stretch compression, that A term, so it's just this guy right here. It says how fast it's going to grow. It's not like slope, it's just how our quadratic changes. Our stretch is going to be 4. My y-intercept could be found from standard form, so I could multiply this all the way out. I'll do it down here. 4 times x squared, so x times x gives me x squared, plus 6x minus 2x minus 12. So 4x squared, that makes 4x when I multiply together, plus 16x minus 48. So now that it is in standard form, I can see my C term here at the end, which would be when I plug in 0 for x, what do I get out for y? It should be negative 48. I could have also done it by just using that idea. If I plug in 0 as x, I get out my y-intercept. So I could have done it right here and said 0 minus 2 gives me negative 2. 0 plus 6 gives me positive 6, and then I still have my times 4 out front, so I would have gotten negative 12 times 4, still gives me negative 48. So that's another strategy to figure out your y-intercept. All of them coming from the same big idea, which is the y-intercept is when x equals 0. Vertex from this form, a couple of different things we could do. We could go from standard form here and complete the square. We'll come back and do that later because we don't actually have to have vertex form. We just have to figure out the vertex. So my vertex is going to be right in between my two x-intercepts. So let's say I've got an x-intercept here at negative 6 and one here at positive 2. One of the key features of quadratics is that it's a symmetrical shape. So halfway between these two is going to be where our vertex is. It might be up here, 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 somewhere along that line. We don't know where along that line at this point. We just know that it happens to be there. We actually know that because this is positive 4, that this guy's going to open upwards, so it's definitely going to be down here somewhere. So that would be like a common sense red flag. If you got a number up here, then you would definitely know you'd done some math wrong. So what's halfway between negative 6 and 2? Well, I can average them by adding them together and getting negative 4 and then dividing by 2, which would give me that my line of symmetry is along this line x equals negative 2. Well, if I know that my vertex is on here and I know what the x value of my vertex is, then I can say negative 2 comma something is my vertex. And anytime I know what the x is, just like the y-intercept, I can take my -2 and plug it in. So I would get -2 minus 2 gives me -4 from that part. -2 plus 6 gives me +4. And then I'm going to multiply by my first 4. Kind of got a little out of order there, but it doesn't matter because it's multiplication. So 4 times 4 gives me 16, times 4 one more time gives me 64. And then this guy's negative, so it's -64. So we're going to come down. I guess our scale would have to be really big, but we're going to pretend like this right here is the value to -64. And then our y-intercept is at 48, so I don't know, maybe it's like there or something. We're just sort of making a sketch using our key features. So just like when we're graphing a linear equation, we find the key features, put them on the graph, and then sketch our shape through them. For a quadratic, our key features are the vertex, the x-intercepts, the y-intercepts, and then the stretch of it. You could really just choose these three. If you got these three features on the graph, you would definitely have a good looking quadratic. So that should be enough to get us through the graphing from factored form. I'm going to come over here to the back side. Now the back side is no longer giving us things in factored form, so we're going to go a different way. What kind of form is this? This is vertex form. So that means the vertex is the opposite of whatever this number is and exactly what this number is. So -2, -4. The y-intercept is when x equals 0. Let's plug in 0. 0 plus 2 squared gives us 4 minus 4, which is 0. I'm going to make my little sketch over here. -2, -4, and then I have a y-intercept at 0, 0, which actually is very helpful because if the y-intercept is at 0, 0, that means my x-intercept is also at 0, 0. So I could come up there. Could use symmetry if I wanted to and say that if I go 2 over this way, I get an x-intercept, so I could go 2 back and also get an x-intercept. But if I didn't want to go that direction, I could always multiply this all the way out and then factor it. To multiply this out, don't make the mistake of saying that it's x squared plus 4. Come back to your box and say that this is x plus 2 times x plus 2. Figure out what your four quantities are. X squared, 2x, 2x, 4, giving me x squared plus 4x plus 4. And then don't forget this guy, minus 4, okay, is going to give us x squared plus 4x. If I wanted to factor that, this is a greatest common factor question. So you could write this as x times x plus 4, which would again give us x-intercepts at 0, 0 from this guy and -4 for this term. Okay. I've got my three features on there. Make a sketch. The stretch is always going to be whatever the a term is. This guy has one that's not noted, which means that it's just a stretch of 1. So there are two examples, one case going from vertex form to the key features, and one going from factored form and identifying the key features. So two examples for you to work through.